Hi, all of you. So we're continuing on to part 5 of skeletal system, chapter 6. What we want to look at now is what does fetal bone look like? So think of a little embryo developing like here, and we want to be able to see my pen. At what point do you start to see bone? Do you see? You can actually see bone here. So the embryo, the skeleton of an embryo begins very soft. And really what it's made out of is cartilage, like you see at the ends of long bones, and membrane. That's all it is. And this bone formation begins about 6 weeks after fertilization. So it really is amazing to think about. And the question is, how does it form? So there's 2 very different ways in which bone forms in a little developing embryo. One of them is called intramembranous ossification. So ossification is becoming bone. And the other one is called endochondral ossification. So right away, you should think this has to do more with a membrane, and this has to do more with cartilage, because chondral is cartilage. So let's start out with the intramembranous ossification. This happens mostly in the bones of the skull, and for some weird reason, also the clavicle. So skull and clavicle is what you're thinking of. And what happens is you have osteoblasts, remember those young cells, in the fibrous membrane, and they are the ones that are secreting the matrix. Remember, the matrix is everything that's going to harden around those cells. The matrix becomes mineralized, so just think you have these specialized cells, they're sitting there, they can divide, and then they're able to secrete all this hardening material that's going to make bone around these cells that are going to become osteocytes, right? They also form that spongy bone between the 2 layers of the compact bone. So if you look at a fetus, and this is a 10-week fetus, you see that in the skull, this coloration is very different, isn't it? This intramembranous ossification is going to produce the skull bones. And then, look, you're seeing these other bones that are formed in a different way, right? You're seeing the ribs. Oh, this is so amazing. The hip bone, right? This is going to be the femur. And you don't really see all the pieces yet, but they're starting to be there. But what happens here is quite different from what's happening in this section here. So in the skull here is intramembranous. It's more of a membrane, as opposed to the endochondral ossification. And that is going to form from cartilage. It occurs in most bones of the body. So the majority of the bones of the body are going to be formed from a cartilage. So let's look at it in stages. If you could do that and break it down into stages, what you'd first see is, like, just take this region of the finger, for example, and what you would first see is this whole region of a tissue that's hiding cartilage, like the one that you look at in lab, that I'm having you look at. And around it is this layer called a around chondrium around the cartilage. And that's all you see. So what's not a bone at all is just a big long piece of cartilage. And then as it progresses, it's going to form something called the primary ossification center. And the primary ossification center is where you start to actually see these bone cells. So I'm very in the center here, right? These bone cells are starting to form here. And they tend to be in this center region of a long bone. Even, in your finger, still a long bone. And as it continues along, there's what we call vascular invasion. So before it was just a group of cells. Now you're going to see more and more arteries that are reaching those cells, so as to be able to irrigate them and bring them food and oxygen and all that. And there's a formation of a marrow. So it's not solid, but there's a space in there now. And we begin to see that formation of new cells, which are bone cells, in a different spot. Used to be just in the center. Now it's going to be in the extremities here, and in the other end. They didn't illustrate it here. That would be the secondary ossification center. And the next step is blood vessels arriving to that secondary ossification center that now has a marrow, so it's sort of carved itself out. It was first solid cartilage, then it deposits bone, then it makes a cavity, and it brings arteries to that area. We call this very middle region of the bone the diaphysis of the bone. We call the extremities the epiphysis. So epiphysis here, and this would be another one, another epiphysis down at the other end. And what's between those two, between the diaphysis and the epiphysis, would be the metaphysis. Okay, so in this model, no, it's not just tissue that's becoming bone, but it's first going to make like a whole new blueprint out of cartilage, and then that cartilage is going to convert to bone. What's left behind is a little bit of cartilage right there, right? And over here also in purple. This piece is going to stay in the metaphysis, and that is called the epiphyseal plate, or better known as in regular English as the growth plate. So it's from there that you're going to grow your long bones. So if all of it were to become osteocytes, then there's no location for it to grow. It's a child growing up. So this cartilage here is where more bone is going to be deposited, growing in that direction and growing in this direction and depositing some more bone in this region too. So it is literally the growth plate. And those then, if you were to take an x-ray of a child's hand, you would see that it looks like, oh yeah, bone up here, bone in the middle, bone on the other end covered by cartilage, but there's a region there that doesn't look like it's bone. So it's that reserve cartilage there from where new bone will be manufactured. There's some really nice videos of this, so I've posted them for you to look at. The other thing is that the articular surface here will eventually, it will have its own cartilage, which is going to cushion it because it's going to be another bone coming up here. But eventually the adult bone is not going to have the epiphyseal plate anymore. A line may remain there, but that's all you see. And there is no longer any cartilage in that area. Compact bone, marrow cavity, and solid spongy bone. So as a summary, blood vessels in this kind of endochondral ossification, the blood vessels are going to grow around the edges. They penetrate that cartilage. Osteoprogenitor cells from blood differentiate into osteoblasts. Remember, osteoprogenitor cells are the ones that are undifferentiated. They're going to become osteoblasts. They're traveling to that region from the blood. That bone formation is going to spread from that original region, which is the primary ossification area. And remodeling is going to occur, creating marrow. So it's going to chew out the middle, and you have the marrow, that center, hollow center of the bone. Bone becomes thicker, and the epiphyses are replaced by bone in secondary ossification. And don't forget to watch the Amgen videos that are available there for you. Okay, I'm going to stop this one now, and I think there's probably one more video for this section. Thanks for listening.